I'm Cornelia from KoruKai Herb Farm. We live on Banks Peninsula and we have a pretty much a self-sufficient lifestyle. We have a big veggie garden that feeds us all year round. We have a dairy cow, beefies, sheep, chooks and ducks. We grow medicinal herbs commercially and we run workshops on fermentation, on the gut microbiome, on organic food production and soil microbiology. We've been growing food and herbs organically for over 7 years now. We still keep learning and improving our system and dealing with organic waste in the best way possible to enhance the soil. We've been using just a small biochar burner for about 2 years now that we use just in our log burner. But we needed something to be bigger. We wanted to be able to burn more and use about 10% of volume in our compost, which we couldn't do with the small burner. And we were lucky enough that friends of ours invited Dennis to teach about biochar on their farm. And he showed a really easy DIY kiln. And yeah, that was a massive, massive improvement. So we could do it on a larger scale. Dennis is a massive inspiration. He has committed his life to sustainable food production, both as a commercial producer, researcher, and with over 40 years of experience. He has a strong interest in organics and sustainable growing methods. Yeah, his record is pretty impressive. He has been co-chair for 3 years at the Soil and Health Association, 5 years chair on Organic Farm NZ, which is a small scale producer for organic certification. And also on the BioGrow New Zealand board, a member for 3 years. Now he's the managing director at New Zealand Biochar Limited and is the founding chair of the Biochar Network New Zealand. So it seems he's committing his life now to burning and yeah, sequestering carbon. It's really amazing stuff. What I love about Dennis's work is that he promotes low-tech methods, because biochar can be very high-tech as well, but it can also be low-tech and it can be sustainable on a small scale at your own farms. And this, for me, makes biochar production very accessible for everyone to implement on a farm or even in a home garden setting. So Dennis is going to introduce you to biochar now. And after that, I'll share the kiln that Dennis promotes, that we produced during the national lockdown on our farm. And at the end, we hopefully have some time for questions. So please submit questions in the Q&A box, which is on the bottom. You can also use the chat box to say hi, say where you're from. We've got loads of interesting people on the call. Some people are logging in from the UK, Australia, and the majority from New Zealand. Yeah, but do use the Q&A box for questions. And we don't use the raise hand function, so just ignore that. There's too many people on the call for that. So over to you, Dennis. Now, hang on, unmute.
Okay, hey, thanks, Cornelia. That's a very lovely introduction. And I do appreciate the opportunity to take part in this, actually. I have to say, it's my first presentation via a webinar, but I believe there's others coming up, so that's cool. I'll just get straight into it, I think. Thanks, Cornelia, and I'm going to share my screen. So, okay, let's see what's going to happen next. That's the way. Okay, of course, what is biochar? Well, biochar is something I've been messing around with for the last 10 or 12 years, actually, and it is really going to be a game changer, I believe, as we go forward with the various challenges that we have. But more specifically, biochar is charcoal made for putting into the soil. And it's made by heating organic matter in a low oxygen environment. And it's just charcoal that can last in the soil for a very, very long time. And that, among other things, is one of the very important factors. Why would you want to use biochar other than to have it in your soil? Well, biochar can do a whole lot of good things, and I'm sure some of you will have already read about this over in the internet and other places. It can just do a whole range: soil moistures, physical properties, biological activity, holds nutrients, improves fertilizer effectiveness, and reduces nitrous oxide, etc. And I'm sure you can read through, and it lasts for that very long time. Now, I'm specifically interested in biochar when it's applied to the soil. In fact, biochar can be used for a whole multitude of things. For example, water filtration. It can be used for improving concrete. It can be used as a road material, as a small proportion put into the seal, and it can reduce the amount of materials required that are more expensive, that are hydrocarbons, etc. So I'm not going to go into that this evening, but it's a very, very versatile material. And indeed, in the soil, it has a function, and but it also is a way of sequestering carbon from the atmosphere and putting it into the soil, sequestering it into the soil. Most of you may know that, of course, plants take in carbon dioxide, and that is used to make the sugars and carbohydrates and all of the compounds that make a plant as it grows. And in the natural way, it grows to maturity and then dies and is decayed by the various microorganisms and returns basically back to the atmosphere as CO2. A small amount will hang around for some time as humus, but invariably it largely goes back to the atmosphere. So it's the carbon comes down, it breaks down and goes back into the atmosphere. Now, if we interrupt that at the point where it says pyrolysis, we can take some of that material and heat it and make biochar. And when we put that biochar in the soil, it will stay there for a long time. And we can get around 30% of the carbon from a plant or of the material that you pyrolyze that will be turned into charcoal and remain in the soil forever. And the 60 to 70% of the remaining, of course, is converted back to carbon dioxide and goes back to the atmosphere. Soil carbon generally is critical to sustain soils. One of the problems we have with modern agriculture, and it's not just the farming process that's the problem, it's the politics behind all of this. But soil carbon is required to have good structure in soils, and that provides for water holding and nutrient holding and drainage and aeration and for microbial activity to occur. And if those things aren't in the soil, if the soil is cultivated too regularly or poorly, if the ground is left bare, etc., you can lose your carbon, and consequently you lose a lot of the functions, almost all of the functions of the soil without your carbon, without your microbugs, etc. Of course, soils are different. We all know soils are different. And in this case, I have an example on the left where the bottom left-hand corner, you can see a kind of a pale coloured soil to depth. Now that soil has occurred as a consequence of regular flooding. And in the picture up in the top left, you'll see a big flood. These floods bring silt and they layer it upon the soil and they drain away. And as that happens over, say, 500 years or even 50 to 100 years, you slowly but surely build up the minerals in the soil, but the plants don't actually get a lot of time to contribute organic matter to the soil. So it's a pale soil, it's a soil with quite a low organic matter, except for maybe in the very, very top layer. In contrast, if we went to the other end of the scale, the prairies of South America and North America and the steppes in Russia have these very deep soils, and they are just very ancient soils. They've been, plants have been growing on these soils for hundreds of thousands of years, I guess. And of course, that's led to an accumulation of organic matter. The interesting thing about these soils is that they also have carbon, as in charcoal, in them. And this carbon has originated from fires that have burnt through the grasslands of these areas for thousands of years. And it's recognized that this carbon, which is sort of pyrogenic, they describe it as pyrogenic carbon, is biochar, and it contributes a measurable percentage in the natural carbon of the soil. So when we have soils that we are trying to grow crops, etc., on that are low in carbon through natural reasons, then we can modify that now with the likes of biochar or through composting and good husbandry, returning our residues back to the soil. It's a complex matter, and it's a very it's an amazing setup, really. Now we have just begun to really focus on putting charcoal back in the soil. That's not to say that gardeners and small farmers and all sorts of people haven't been doing it, but in fact, back about 5,000 years ago or so, if not longer, the native folks then were putting carbon in the soil, and particularly, it's a very classic example is in the Amazon Basin in South America, and there they have areas which have been created by man by putting amounts of charcoal in the soil for cultivation and for growing food on, which is quite separate from the natural processes of nature. And these soils are called terra preta. They are the black soils. And they, 5,000 years or more later, are still holding more nutrients and water and those sorts of positive characteristics, having not had any further additions from probably several thousand years. So it's a remarkable characteristic of the charcoal. This slide shows the comparison. There are large areas with charcoal that have been placed there by the ancient folks, and there are nearby areas, of course, that haven't had that, and they are so different, and they are just side by side. And it's thought that this is the reason why some of the stories of ancient cities in the tropical regions, many people, until recently at least, have wondered how did they manage to grow sufficient food? Because in tropical areas, we struggle with our soils because of the heat and the heavy rainfall and the circumstances around the climate. When you come to cultivating and disturbing the soil, you have difficulties maintaining the carbon. And yet here we have these terra preta soils, which are just remarkable in their demonstration of what can be done. So just in summary, you'll see there that burying charcoal gives those long-term effects to the soil, and along with the fact that it's also sequestering carbon, a point which is very high on our agenda at the moment, considering the impacts of climate change. So, how is biochar made? Well, I explained earlier that by heating organic matter in a low oxygen condition, which is called pyrolysis, that's how you do it. And you might argue, you ask, what does that really mean? Well, if you were to put a piece of wood in a cake tin and put it in the oven, and as long as your oven could go up to 750 degrees, you could heat that piece of wood, and as long as there wasn't any oxygen there, it would start, well, number one, it would start to give off gas at about 280 degrees to 300 degrees Celsius. And after that, it would continue to give off gas, but the remaining part of the wood would become charred. Now, if there was oxygen there, then that oxygen would burn the gas or ignite with the gas, but it would also burst into flame with the charcoal. If you keep the oxygen out, both the gas and the charcoal won't burn. And as you increase the temperature, more and more of the sample will actually go to gas, and to the point where finally you would actually gasify it completely if you were at about 900 to 1000 degrees. I'm going to talk about how, I'll give you a diagram shortly about this process, which might help. And of course, when it comes to putting material into your, or the material that you want to start with, there's a wide range of materials that you can turn into biochar. In fact, any organic matter can be turned into biochar. But of course, if you're planning to put this charcoal back in your soil, you don't want to start with any material that has contaminants. For example, you wouldn't consider charring tannalized wood with its chromium and arsenic and whatever the third one is, lost it at the moment. Those materials would remain and they would end up in your soil and consequently provide a contaminant that you wouldn't want in food producing soils, or any soils for that matter. However, for other materials, there's a distinct sort of hierarchy of nutrients that you'll find in those feedstocks. The woody ones, as you can imagine, branches, the centers of branches are quite low in nutrients. And then if you go to things like corn cobs, husks, rice husks and straw, those materials tend to have more nutrients in them and so those nutrients are actually obtained in the biochar. There's the nitrogen, some of the nitrogen is lost, but other things such as magnesium, calcium, potassium, they will remain and be available, plant available, once the biochar is produced. And then when you're doing things like manures, chicken litter and that type of thing, you get a much higher nutrient loading in your biochar. Most of us wouldn't be bothered charring those types of materials. They're far better used in compost. Most people best charring things like their prunings from woody shrubs, etc. That would be in an urban setting, and that also in a small farm setting. Although in the case of a small farm setting, there could be opportunities to grow certain crops, specifically for the purpose of making biochar. So this is another characteristic associated with the biochar that is dependent on what you start with. The previous point was that it depends on how high the temperature is that you use when you char. This particular slide is about the type of material you use, and it has different characteristics depending on what you use. Another characteristic that changes with the temperature at which you make the biochar is the surface area and pore volume of the char. They have a very high surface area and they have a very high porosity, which gives it a lot of its positive characteristics, and we'll talk further about that shortly. And as the temperature increases, what happens is that you get more micropores, and that of course gives rise to a greater surface area. The surface area is not so much the surface area around the outside of the particle of charcoal. It's porous, and the surface area is the area of all of the pores that are within the particles of biochar, and these go down to micropores. Having made those few points, and it's quite a complex idea, and it's a very interesting material, and I'm just popping in a few ideas as to what goes on rather than trying to give you the full story. Now, I'm a bit of a fan for the flame cap method. There's about 3 obvious sorts, well, there's more, but 3 types of ways of making biochar. And the flame cap is one. You'll see there's others like a retort system. There are other ways which are not necessarily so different, but they're kind of hybrids, such as a T-lid, a top-lit updraft. But I'm only going to speak to the flame cap method this evening. And in this case, the example is going to be this bowl, or kiln. It's come from ideas from Paul Taylor and Hans-Peter Schmidt. Paul's an Australian, and Hans-Peter's Swiss. And they did a lot of work on a freestanding one of these, and they also suggested this particular style of thing, which they called a hole liner, but I've kind of taken it out of the hole, and it's a very simple process and easy to make. So these 3 slides just show first the sitting it in a bit of a hollow, and Cornelia will be speaking to this shortly as well. You light a fire in it and you get some char. Now, the key point that I really want to talk to is that what goes on in the bowl when you're burning. And this diagram, I hope, can give you some idea what is happening. You start, your first step is to set your bowl in the ground. The second step is to start a small fire, as you would do normally in any other fire, and get that established. And then you layer on pieces of wood so they are flat or horizontal rather than sort of poking up. When you're at the stage of layering on the wood, the heat from the fire below heats the new piece of wood, and once it reaches that 300 degrees, it starts to gasify, and the flames then start burning in the gas, and this is what causes the flame cap. You've got all of this wood is producing gas, and your fire is sitting above the wood. So there is no oxygen available below where the material is charcoal. So the charcoal accumulates. It doesn't burn if everything is going well, it just accumulates. So it's quite simple in its concept, but there's all sorts of sophisticated machinery that can do this in a more qualitative way, but this offers opportunities to all of us to do this anywhere, well, I was going to say anytime, but not when it's wet. So just to refresh, it's a fire that you start, then the next set of material you put on, that fire is heating that new set of material, that gives off gas, and that forms a cap over the top. And once that starts to get to the point where it's gone black and then starts to ash, you know you should be putting more wood on, and you can fill this bowl completely, well nigh to the top. So I've come and gone across different ideas, but I'm back to how does it work. So got a couple of photos here, starting from wood chips to biochar, and looking more closely at what has happened with that biochar is that it's changed internally, but in fact, if you have a small branch and you sit it in this heat, it doesn't change physically, and that you still see it as a small branch unless you put pressure on it, and it'll break down. But it's full of this micropores and macropores, and this has all happened through the heating process. And it's actually changed in structure. This is just to indicate to you that while it was a piece of wood, it was a series of molecules that have their carbons in a straight chain or in various straight chain connections. Once it's been heated and turned to char, it's actually changed the molecules to an aromatic ring. So it formed a ring. Now, that is a very stable structure. When you have the straight chain, microorganisms and other decay processes can attack that material from the edges. When it's in an aromatic ring, sure, it can fiddle with the little molecules that might be hanging off that ring, but they cannot or don't seem to be able to break the bonds between those 6 carbons. And that is why the biochar will last an extremely long time in the soil. And it just forms big collections of these rings, and so is a very stable product with various small pores and large pores between. But it's a straight chain, and it changes to a ring structure, an aromatic ring structure, and that's what gives it the stability that makes it so valuable as a sequestering carbon or sequestered carbon. Whoops, hang on, what have I done? Oh, there must be a way out of that. So, because of the pores, it's a great place for microorganisms, bacteria and fungi, fungal hyphae. This slide, the filaments are from a fungal hyphae, and when you have a soil with this type of structure in it, even when you cultivate it, particularly with bacterial activity, it's very hard for it to sort of dry out completely or be cooked by the sunshine or whatever things are that kill off your microorganisms. They can be way inside a tiny little micropore and still have their total environment to, irrespective of whether they're near the surface, exposed, almost exposed, being exposed to the soil, to the sun for a short time, whatever. And this is another very important aspect, the ability to look after the microorganisms. Lots of experiments have been done with biochar. In the last 10 years, there's been more experimentation, I believe, than there's been on compost. More experimentation on biochar than there, like research papers, than there are on compost, which is a pretty amazing outcome. At the beginning, there was concern that in fact sometimes when you put biochar in your soil, you could actually cause a negative effect on your plants. And that of course was a bit disconcerting. However, plants do like biochar. The reason that negative effect might occur is largely temporary. It's associated with the fact that within the biochar itself, there is a small percentage of carbon that is still available for microorganisms to chew on. Well, this is my kind of picture I have in my mind. Some other people have other ideas, but I see this as the sort of smoke products that would have drifted off had they not been in the pores, sort of settle on the walls, and microbugs come along and they can consume that small proportion of carbon that's in those particular materials. And in doing that, of course, they draw on other nutrients from the soil, such as nitrogen particularly. And as a consequence of that, sometimes if you've got a high loading of biochar and without any additional nutrient to balance it, then they will draw from the soil, and that can be a negative aspect. So invariably, you need to be adding a little bit of nutrient when you apply your biochar to your soil. Well, we'll talk further about that one as well. And this is another experiment that was done up at Bannockburn, and the vineyard owners there had a nice plough, and they wanted to try biochar between an existing rows of vines. So they ploughed a strip, and we put in various rates of biochar. And in fact, we had proportions of biochar mixed with compost. And what we found in that experiment over 2 years, it was relatively short, but it was still 2 years, was that we the biochar had a synergistic effect with the compost or on the compost, so that the nutrients that were in the soil or applied as fertilizers, soluble fertilizers, there was more held in the soil over and above what you would have got from just putting it on with the compost and any basal fertilizers. So the biochar invariably is finding in all sorts of places. It will actually give you an extra efficiency around the nutrients that are held in the soil. And this is associated with microorganisms growing and consuming, and so stabilizing the nutrients in the soil so they're not readily washed away. And there are chemical bonding sites, as you might recall thinking back, which can hang on to nutrients. So biochar in itself can have quite low nutrients or no nutrients, but when applied with other nutrients, it can give benefits over and above what the fertilizer alone could give. I popped this in here just to highlight that around the world there's a lot of work done to characterize biochar or chars, because there's such a variation in what you can produce depending on what you start with and what temperatures you take it to, and there's a range of other little things as well. So there have been tests devised that will give you some ideas about the quality of your biochar or the characteristics of your biochar. And in this case, you might see there a thing with a hydrogen to carbon, organic carbon ratio. This is something that will tell you how well charred how well charred your biochar is. And so there are other things like the amount of ash. One other thing that is quite significant with biochar is that it has a liming ability. In other words, it acts like putting on lime depending on how much you use. So that's a valuable asset as well. Going back to that idea where the bugs can consume some carbon and cause a negative response. This is more, it doesn't happen every time, but it can happen. And my recommendation for anybody who's using biochar, particularly fresh biochar, they should consider mixing it with some nutrient. And in most cases, things like chicken manure or or some other manure is ideal. I mean, if you had nothing better, you could use some urea and some other nutrients like that, but mostly using some natural fertilizers is by far the best. And the other very significant way of using your biochar is by adding it to compost. And it makes compost, well, while making compost, when you're layering your materials together and you include biochar at that point, it will absorb some of the gaseous nutrients, particularly nitrogen, so that they are not lost as you might sometimes lose in a normal composting heap. They also, the char will also absorb some of the liquid, which is going to have nutrients, so you have less loss of nutrients that way as well. And in general, it makes the process go more quickly and can take a noticeable amount of time off the length of time required to make compost and get to that nice friable stage. So many people around the world are using biochar in making compost or mixed with compost. There's lots of good reasons to do that. So when you're using biochar, there's recommendations of about 2 millimeters in the literature, but there's a lot of energy and issues around fine grinding, because biochar, you need to have it moist most of the time, otherwise it can be a safety issue in terms of dust, fine dust. And I just, well, invariably when I complete a run of making biochar, it's put out with water so it absorbs and a lot of water and is wet, and then that keeps the dust down. And I have a sieve that is about 1 centimetre in its diameter, and I crush it through that, and I just take a range of material and use it on my land. I prime it with some nutrient by a very sort of not too specific measure. I just take some liquid manure and put my char in it and soak it for an hour or so. I mean, if it's in there for a week, it wouldn't matter. If it's in there for an hour or so, I make the assumption it's going to be fine. And then you can either dig it into your garden or layer it on the surface if you've got perennials. And as time goes by, the worms will take it down into the soil and other organisms. It's amazing that it disappears down into the soil. Just making the comparison between biochar and compost. There are two forms of carbon, and biochar, this is someone's piece of work, and it just goes to kind of highlight that over the first sort of 10 years, and I think in many cases even more quickly, your compost will go from 100% down to say 30%, etc. Whereas your biochar just stays forever and ever and ever. It doesn't mean to say one's better than another. They're very complementary, and both need to be in your garden or in your soil. I wouldn't say one should be used as compared to another. They're very complementary. And of course, your compost has a good load of nutrients in it. So they work extremely well together. Now, this, just to give you a little sense of the sorts of things that you can make biochar with, there was a lot of work went into little stoves for third world countries. I'm never quite sure where the third world countries are. Sometimes I think New Zealand has a touch of third worldness. But they are good. You can make charcoal while cooking and boiling water and doing other things, and they function well, and there's been a lot of them used or in use around the world. You could take half a drum, or take a drum, cut it in half, light on its side and use it. The cone is probably the most effective shape for efficiency, but there's not a lot of loss in terms of some of the other shapes. On the top right, you can dig a pit and make charcoal that way, just using that as your bowl. A small kontiki there on the bottom left, and then some large troughs, which can do quite a volume at any one time and they all work according to the amount of material you've got and how you want to use it. A further series, a larger kontiki, there's a kiln. This is on the top right. These are kilns that are at Timaru. Company Waste Transformations is using it to reduce some of the timber offcuts from the building industry. They can be terribly sophisticated, as the bottom left, with capture of the gas, etc. So you can get energy as well as the biochar. And then on the bottom right, there's some really large kind of open machines, like big machines, that are working on the same principle as what I've just described. And then, of course, you come down to your own small backyard jobby, which can be a purpose-built cone, or you can find an old, forgotten the name of them, but everybody's had one at some stage if you're as old as I am, and block up the air vent and make some char at the same time as cooking yourself some dinner. So I just want to point out that there's a whole range of ways you can do this. Of course, there's certain efficiencies, and it's with the equipment, with the type of feedstock, all of these things are measurable and are a little different. But for the average person, you needn't get too hung up on all of these specifics, because, for example, the efficiency between, say, an old barbecue and a purpose-built cone, I think would be barely measurable. When it comes down to whether you use wood from one tree or wood from another tree, then it might be slightly different in nutrients or the amount of porosity, but for the general purpose use in the soil, no big deal. And the same with the temperatures. Once you're sort of over that 300, well, more like 400 point, you may have a char that is slightly different, or it is sort of different from one that's made at 700, but the characteristics of each kind of balance out. And particularly for in the soil, the lower temperature ones of about 500, which is what happens in your kontikis and your flame caps, 500 to 600, and those as a rule, ideal. So don't get too hung up on the detail. You can learn and investigate if you're keen, and you may want to tweak how you do things, but don't get too hung up at the beginning. Thank you. I'll hand it back to you, Cornelia.
Awesome, Dennis. Thank you so much. If you could just stop sharing your screen.
Yes, sorry.
Yeah, I saw that.
Is that? No, it's not done yet.
Okay. Good. Awesome. There we are. Okay, so at the workshop with Dennis we did in January, it was very valuable for me to see the actual burning process, and I hope now that I can give you the tools to get started and produce good biochar from the get-go and avoid small mistakes that we did. So yeah, it's good to learn.
Yeah.
So I just carry on here. Okay. So we have used just the sheet of steel, was 2.4 by 1.2 meters. And I just say, it was 1.2 millimeters thick, but I think, you know, at around 0.8 mils, it would have also been okay. It was quite hard to cut it at this thickness, but it's, yeah, very durable. It was the steel we got from Steel and Tube in Christchurch, and one sheet was $90, so quite okay. We also had to get a flat bar to connect the cone together, and that flat bar was $10, and that was actually 6 meters, and we just needed 2 pieces of 0.8 meters each. So yeah, all up $100. So we got that cone. You can look at other, you know, recycling centers if you find similar sheets, or, you know, the same similar measurements or smaller, to make your own cone. But yeah, you're looking at $100. We've got the small, really small burner that we used for our wood fire, and we bought that for $150. So yeah, very valuable to have a big cone, and we make massive amounts of charcoal now with that. These are the measurements. So the sheet's 2.4 by 1.2, and then you basically go to the center of it, and then you're making 2 circles. First, the one on the outside, and then from here you go 40 centimeters and do another circle. So that will be this one. And then inside of this circle, you go, you know, this all up is so 0.4 meters. You go halfway, you get to that point in the middle, and then you draw another circle around here. So 3 circles all up. So the first one was 1.2 meters for the big outside ring. The second one, 0.4 meters, that's this one. And then the third, the one tucks in 0.2 meters radius. And just make sure here, that little line here is connected. We do not cut through that, so that we have that bottom piece attached to the kiln. Optional, you could cut out and handle here. We haven't done that, but we actually think just attaching and handle, maybe with some wire, if you make 2 holes, can also work. I think, Dennis, you had that with yours. You had 2 holes and then attached it with some wire. That's really handy to have that you can tip out the kiln at the end of the burning process and then quench the burn. So Kai cut that out with an angle grinder. We did it during lockdown. It was quite a fun project to do. And that's where the pieces are. So you can take screenshots of that measurements, easy to build. And then there's that flat bar. The flat bar that we chose was 20 mils by 3 mils thickness. So 20 mils width. And so making holes into that, and they get attached to one side of the kiln. And with that attachment, we could drill holes right through and could connect it to the other side. So then we have the holes through and the right distance, same as on the bar. And then Kai was bending it. So yeah, when you do that, just be careful with, you know, all of these sharp end pieces that you wear some gloves and other safety gear needed for that job. So it was quite hard to bend it, but we just carried on bending it. And then attaching that bar to the side, drilling holes in the other side as well. And with that bar with screws, yeah, you have a kiln. We left it open at the bottom. It can be shut, but we left it open. It was just easy to bend it shut. And then was just a steel file. We took the sharp edges off. We did it on all of those sides, at the top and at the bottom, just that it's, you know, whenever we touch it and we have to remove it or put it somewhere else, that we don't hurt ourselves. So that was quite good to do. And then digging a hole, sitting the kiln in and just pushing the soil into the kiln so that we get no air and oxygen through the bottom where it's open. So here you see the soil is coming through a bit, and yeah, we're shutting off the airflow that would come in from the bottom. And with having it buried like that, it sits really stable and doesn't topple over. And then you start a wee fire in the bottom of the, just in the bottom of the kiln. As feedstock, we used dried wood from prunings from the neighbour's property. They usually have massive burn piles, and we have permission to go in there, get wood with our trailer. And yeah, we get bigger pieces as firewood for us, and smaller branches we get for the biochar ones. So you don't want them to be around 7 centimeters thickness, isn't it? 7 centimeters at least. So you can't do massive fat pieces, just those smaller branches are really good. Yeah, with the feedstock of the biochar, it's really best to use something from local, from your farm or neighboring farms, so that you don't have transport costs or that you're wasting fuel on transporting it. Also, when you have it on your own farm, it's your own storage, and you don't need to have collection costs or any costs compared to that. It's best to have it from local source. Best to use waste material, because that's, the air needs to be dealt with. Those, massive burn piles that people have, good to tuck into that. If you drive past a farm, you see those burn piles, just go and ring on the door, ask the farmers if you can get a trailer load. And it's close by, it's really good to do. And they're more than happy to share. Crop residues like nutshells, fruit pips, straw, rice hulls, great to use. Hedge prunings from fruit trees prunings, coppicing material from poplar and willow, or residues from logging. Animal manure, if you want to use that, it needs to be dried. We don't use manure as a feedstock because we use it in our compost, same as Dennis said, because it would take too much time and effort to dry it out. We also use shells and bones. Shells we have, just whenever we eat some mussels, and bones from our cows. We do large beef bones that we add to the compost first. They eat off all the, the hair and the skin and any bits left over pieces from meat. And once it's been composted and the bones are still big, we then put them to the side and use them in the biochar burn. Don't use treated timber, as Dennis has said, and the feedstock needs to be dry. So there was one question already came through on the Q&A. Yes, it needs to be dry feedstock. It shouldn't be wet and green, because you have too much smoke coming off. So now I've just got a wee video here from the burn that we did. And yeah, it's self-explanatory. There we go. So we just start the fire of the biochar burn today. So it's just a wee fire down at the bottom of the burner, the kiln. We have burned it quite a bit today because we're gonna sit next to it as well and have some heat from it. It's quite a chilly day today. So just a wee fire in the bottom with some cardboard and newspaper and some small sticks. I'm just gonna let that burn. Once that burns well, then we're gonna use some shorter sticks. We've already got some ready here. Because the kiln is very narrow at the bottom area, we need short sticks because they're gonna go in diagonally. Is it diagonally? Yeah. Right, right. Maybe I can put the first wood on fire. So the wood goes on horizontally like so. And we don't want any stuff sticking up far to get a nice char. on kind of like a crisscross pattern, in one way and then the other way. Okay, so now the fire is burning really well, and we are about a third up. And now we are just always checking that we get the wood white on the outside, and then we put, it's outside for us to put the wood on. So we wanted white, to be looking at the white area surrounding the wood, and then we're gonna put the next lot on. We put the shorter sticks on each end and the longer ones in the middle, because it's just how that kiln is shaped. Just try to do one layer. Right, just adjust it so that it lies flat. I just cut them to size as we go. We've got wood from the neighbour's boom pile. So that's a mix of poplar and KoruKai. Sauce to the right size pieces. And should be putting on the next lot. And now we're gonna just stop and wait until that is getting black, and then when it turns white, we put on the next layer. Yeah, so that's pretty much it.
Yeah, so that's pretty much it. It is a pretty easy process, but two things that we learned is don't walk away from it, because it can go pretty fast from that you just added another layer and then you walk away 5 minutes, you come back to it and you already have an ashy layer at the top because you were not there to put the next layer of wood on when you needed to do that. So yeah, one that we learned. So you need, yeah, really need to stay with it. Best to cut some various length before you start, so that once it starts, you have something on hand to chuck on, and then chop some other, cut it to size or with a saw. And the other thing was quenching the burn, that we're gonna go in just in a minute. There was another mistake that we did, that we didn't quench it and stop it properly. Yeah, the first burn that we did, we got about 6 sacks of material of biochar. And the second burn, we had a couple of mistakes and we just got 4, even though they were filled up to the same height. So, there was just some ashy layers that we should have avoided and could have avoided with just staying with it. And then, when it's at this stage, we did some, stick bread. Kids love that. And on another occasion, we had some beef stew in there that just got warmed up. And yeah, it's fun to do the fire and have, making biochar as you go, and not just having a, regular bonfire. I love making fires. I'm a fire person. And yeah, I love the benefit of the biochar and not just burning it and you've got nothing left except a little bit of ash. So there was a really good burn. And to stop the burn, you smother it and quench it. What we do at the end of the burn is we spread it out. We sprinkle some water on it until it stops steaming and stops doing that sizzling. And be careful when doing this, because the hot steam, you can hurt yourself. And you can also, if you do it inside a pit, you can also cover the whole pit with soil. That also will stop the process and quench it. The next morning you can then dig it up. Just be careful if it's still warm in places. If you leave it to smolder, it will just turn to ash in a few hours. Like the last burn that we did,
it was really dark and we couldn't see. And so we tried to quench as much as we could, but there was just one pocket where it was sitting in a too large pile. And next morning we came to it. The outside head was biochar, but in the center it was all ash. So we could have avoided with quenching it properly. Yeah, lesson learned. So yeah, having torches there if it gets late, and do that properly to quench it. So that was the next day. So we came back and it was nice and charcoal. So we did just tip it out and quenched it with water. That was what we did on the day. We also did some bones. I did it in a different burner. So, you know, it was a big beef bone. And then you can break it to pieces. It's really, really pretty. There's some I did in avocado stones and they turn into that really beautiful blue color. You can charcoal a lot. This is shells. They look really magnificent. And you have to be really careful because to take the photo, but then after you crunch it, it just turns into pieces really easily. So that was from the first burn that we did. We got those 6 sacks. And it's massive effort. But you really need to be onto it when you do a burn. I've heard some people saying, oh yeah, just dig 5 or 6 pits and I make the fire next to my burn pile. And I said, yeah, good luck with that. You need to be onto it to have the wood cut to size, and maintaining 6 would be a really hard job. I think you need like at least about 1 person with each pit that you do, and have that person be onto it and adding fresh wood as needed. We did a couple of things to activate it. Dennis has already talked about that it needs to be preloaded, otherwise it's empty material. When you add it without preloading it, when you add it to your soil, it just soaks up water, soaks up nutrients, microorganisms retreat into that, and it just takes nutrients and water away from your plants. So you want to preload it, get those pores filled with nutrients, microorganisms and water, and then adding it to your soil. We feed it to our cattle. We stomp it quite fine and feed it, so it goes through the rumen and it gets pooped out with the manure. It's perfectly charged, and then the earthworms just take it into the soil. You can use equal parts of cow manure and biochar and just let that sit, keep it wet for a couple of weeks. That charges it. We add it to our compost toilet. So we've got a bucket system in our compost toilet, and at the bottom we add about 1/4 up with just biochar. So it soaks up urine, the pee, and gets charged as we go. And then that compost toilet is then used to make compost. So it's just one small part of our compost heaps. The kids have used just some buckets outside that they added some biochar to it, and they use it outside when they need to go to the toilet and pee on it. And yeah, once it's covered, you just let it sit for another couple of weeks and then use it as is in the garden. Layer it into the compost pile. We use about 10% by volume. You can also use vermicast. We find vermicast really good because it has those microorganisms that are eating the bacteria and the fungi to do that nutrient cycling. As was like Dennis pointed out, at some stage biochar can be not beneficial because it takes up those nutrients and the microorganisms, and then you need those nutrient cyclers, the protozoa, the flagellates, the amoebae, the nematodes, to then eat those bacteria and fungi and release those nutrients again. So we find vermicast really helpful. So adding a bit of vermicast, using compost in addition, and to charge the biochar. There's some useful websites, the Biochar Network of New Zealand. There you can find Dennis, New Zealand Biochar Limited, All Black Earth, soilcarbon.org.nz, on our KoruKai blog. If you go to korukai.co.nz, we'll do an article about biochar. We've got articles about soil microorganisms, microbiome, making compost. Yeah, all of that. I've got another webinar coming up end of July. Some people did both. They joined this webinar today, and they also signed up for the biological gardening one. You can see some of the topics that we go through. So it's thermal compost making and really talking about the soil food web and what it does. And yeah, biochar is just another layer in our system to give, more sustainability to deal with waste on the farm. Thank you so much for your interest. I'm just gonna stop sharing my screen, and we've got some questions that people have. So the first one, really great questions. Can we use driftwood, and how dry does it have to be?
Are you wanting me to speak?
Yes, please. I
Well,
have got an idea, but I want your opinion first.
well, yes. There's a concern that if the salt in the sea, in the driftwood, might produce dioxins. I think it is dioxins. Yeah, I don't know how significant that problem is, but that's what people say. That's about all I'm going to. Yeah. So.
Yeah. I'd also add, you don't know what wood it is and where it's come from. It could be treated wood. You've got toxins in it that you don't know about. But if you got nothing else, I don't know. It's a hard question. Better to go with something that is safer.
Well, the point being, we've had a lot of nice driftwood fires on the on the beach over my lifetime, and I haven't thought about the issues of those issues. So I think I would check it out. I can't say you should do it, but I would say that I would be tempted.
Yeah. Okay, one question. What I don't understand is, if it is pyrolysis, how is that without oxygen in the open pit? Is the cap part the thing that somehow seals the fire so oxygen is not getting in? Yeah, exactly. So at the top, you've got that fire burning. Down below, there's no oxygen reaching that down below. So biochar is happening down below. You've got that fire on the outside of your logs. And once that starts to turn black, and then it's just a whitish layer, it just happens within a few minutes, then you add the next wood on, and your fire gets transferred from that wood to the one on top. And yeah, at the top you have that cap. No oxygen can go into the bottom. So you have the heat in the bottom, but not the oxygen. And then yeah.
A pit is just a shallow cone.
Yeah. Yeah, exactly. Pit is the same as the shallow cone, yeah. Could I please confirm the thickness of the steel sheet? The thickness we used was 1.2 mils. I find it quite thick to cut. Dennis, what thickness have you been using? Do you know?
Yes, about a millimeter is good because it's got some of its own strength. But I, in my travels, have cut sheet metal with kitchen snips and made a cone. So that's very, very thin, and it worked fine. And the people used it a number of times afterwards as well. So really, it's just the practical, holding its own shape, and also the number of burns. When it's very thin, I've rolled it up and put it on the back of a motorbike and taken it to the next place.
That's great. Yeah, so around 0.8 and 1 mil I wouldn't get. Yeah, that's around about.
Yeah, I agree. Ideally, that would be my recommendation.
Yeah, and the one that we bought was 1.2 mils, and that was $90. And the one for, was it 0.8 mils? You could get for $60. So yeah. There was one question: how long does the burn take for the 6 sacks? Oh, how long did it take us?
3 or 4 hours?
Yeah, I would have said, yeah, 3 or 4 hours. That filled up the kiln pretty much to the top. And yeah, it does sink down again as it breaks up. It does sink down, and yeah, it took around 4 hours. Just getting to the next questions. Are there some articles or research you can point us to, like the Bannockburn wines result? Do you know of any research?
Sorry, what
Like
research?
the grape vineyard that you were talking about, is that research online? Can people find that?
They can find it on my website.
Okay.
But there's all sorts of research. There's the International Biochar Initiative, IBI, perhaps you, but the Ithaca Institute has some very good articles. Ithaca. If you were to Google Ithaca and biochar, you'll get articles from the Biochar Journal. But there's something like 10,000 research papers being done on biochar.
Yeah.
It's massive.
Yeah, do a Google. There's heaps, and there's lots on Dennis's website. There's other resources that you can find, and you can join groups online. And yeah, there's a lot out there. One question by Miss Goodwin. The city councils, for example, in Christchurch, they have tightened up on wood burner requirements because of the harmful emissions, particularly from the wood burners, which slow the oxygen flow. Isn't biochar emitting these same undesirable emissions?
No.
No.
Can I? It's been measured as being cleaner than an open fire in terms of its emissions, and but really the stipulation is that it needs to be dry feedstock, and I think the emissions that come from a lot of burners in domestic situations, they're probably burning quite a lot of moist or wet wood, even if they think it's dry. It's the same with making the biochar. If you use wet wood, you get smoke, and smoke is steam that is carrying away particulate matter like the fine charcoal and ash. So no, if this is done with a certain amount of rigor and not generating any smoke, it will be as good a process as you can get. It's amazing, and the work has been done to measure the emissions.
Yeah, awesome. A question from Simon: how big is too big? I have a 1,400 litre stainless calf milk vat and an almost unlimited supply of waste Christmas trees to feed it with. The vat has vertical sides. Flame kit should still work, I think. What do you reckon, Simon?
Yep. You can, yes, I've forgotten what they called it now, but particularly there's people in the States have just got big, straight walled boxes that they clip together, and it's a matter of having enough material and getting it in there quickly enough to keep your flame cap. That's the problem. Otherwise, it'll start burning in one corner into the charcoal. But if you've got a method of getting the material in there and getting it burning and keeping it busy, sure, no problem.
Yeah, awesome. Yeah, well, worth a try, definitely. Use stuff that you have, and you know, you don't need to build something that if you've already got something, then use that.
Yep.
Did you tip the burn out, then quench, or did you quench in the kiln? We tipped it out first and then quenched it so that we could spread it.
There are.
And Kai also said we put water first in the kiln and then tipped it out to quench the rest. The question is, can we just tip enough water and to pretty much fill it up and have it quenched?
there are the freestanding kilns, which are the same shape but sitting up on legs. Many people have them so they have a pipe in the bottom, and you can put the water in from the base, and there's no steam, and you can collect the water again when it comes out, and it can have some nutrients and value, or you can reuse your water. So ideally, because it does take quite a lot of water when it comes down to it. It's one of the difficulties in some respects. But if you are serious, ideally you have a pipe leading into the base of that cone with a shut off so that the air can't get in. And then when the time comes, you plug a hose onto it and just fill it up and then drain it back out again.
But you can do it from the top too.
Oh, certainly, yes. Yeah. But of course, again, you get the steam, but that's right. Yeah. You can just fill it up from the top. Yeah. But particularly if you've got a cone like Cornelia was showing and what I've shown, if they're not completely sealed at the bottom, the water will run through and you won't be 100% sure of whether you've wet it all down.
Yeah.
It's effectively, as you've explained, with a kiln like that, any small kiln, better just get it out on the ground, spread it around a bit and put it out then. Otherwise, you'll lose your charcoal almost without,
Yeah, don't walk away from it and just let it sit. You have to quench it. That's really important. Dennis, how many burns would you expect to get out of a steel cone like this before it oxidizes too much and falls to pieces?
I would say, I don't know for sure because I haven't had one completely collapse, but much thinner, I might have done a couple of dozen or more. Anyway, and it's not that it collapses, but it does weaken. No, I would be thinking 50 or 100 burns. I'm only estimating, but I think a millimetre or 0.8 would go on for a long time. And particularly it probably would be helpful to keep it dry between times. If that might slow down the rusting, but I think it would last probably 100 burns. I'm sure of it.
Yeah, awesome. A question from Joe: are there any wood or trees that are not suitable to use? Short answer is no. Anything can be used. It just depends. It will have different properties, but there's nothing that can't be used really.
It's only any natural woods or organic matter is fine as long as it's not been treated.
Yeah. One question, you didn't mention peat soils. Do you want to comment on the carbon in these soils? Have you got knowledge? I don't know if the peat soil is, I don't know if you can measure the carbon content and say, peat soil has this amount of carbon and other soils have this amount of carbon. I think it depends on the management of the place, isn't it? What do you?
It's an interesting question. I mean, peat is peat, really, it's a pretty. I know there's some very large peat areas, but a peaty's. Well, there are peaty soils seemingly around Pukekohe and other places, but they will be higher in carbon anyway, and they are likely. I haven't got any experience of growing on peaty soils, I have to say.
Yeah, me neither. We are on clay, and we got used to our clay. We love it. Yeah. Well, you got what you have, and you work with it. Clay is amazing to hold onto nutrients and water, and with the right amount of organic matter, it's awesome. If I would have sandy soil, I would like to add clay to it. Yeah.
Yeah,
it's not always easy, but it's certainly able to hold on to a lot.
Yeah, now you need a certain amount of clay for sure.
Yeah. Last question we have now from Edwin. I have a retort.
made out of one 44, what's the G, is it?
Gallon, 44 gallon drum.
44 gallon drum with another half 44 gallon drum on top with the flow. What's the benefit of using a cone system over that system?
Well, I think what you've got there is a T-lud, actually, rather than, well, I might have expected you to describe a retort as a small drum inside a large drum. What you've got, I think, is, and you can correct me if I'm wrong, but I imagine you fill it up with coarse chips or some material, and then you light it at the top. And there's a certain amount of air coming up from the bottom because you've got holes in it. It's hard to know. But putting the top, like a typical T-lud, is a 44 gallon drum that's open at the top, has several holes, like a number of holes in the base to let some air through it. And then it has another piece of 44 gallon drum on the top with a just as you described, and you light that. And what happens is that there's a fire front burns down through the chip material, and the small amount of air that's drawn through keeps that fire going or heated and creates the char. Now, it's very useful for material that's coarse chip. You can't make it work with sawdust alone. You need something that looks a bit like, say, walnut shells, as an example, would be perfect. And you can char those well, and you would char them better in that than you possibly could do in a cone. But for the most part, we all are dealing with things like branches, and you can't, it's more difficult. In fact, it's almost impossible as far as I'm concerned to do branches in that system.
Yeah, he's just posted, it burns top down through the material.
Yep, it's a top lit updraft system.
Yeah.
And they have their purpose, but you do it, it's like a batch. It would take about an hour or an hour and a half to run through that, and you would get about a quarter of a drum, a 44 gallon drum full at best, and of char, and then you start again. And everything takes time and energy, but I'm a real, I've used that system for quite a while. I thought it was the only system for a while, but I'm very happy with flame caps.
Awesome. Thank you so much. No more question. We've done well.
Cool.
So they're either, really tired, ready for bed, or we have done well. Thank you so much, Dennis.
Oh, you're welcome.
Yeah.
It's been a pleasure.